Lesson 3.1 Addition of Polynomials. In this lesson, we will learn how to add polynomials and solve problems involving algebraic expressions. When we add polynomials, we can actually do the following: add horizontally or add vertically. Let us have an example to better understand the two methods. Let's say we are asked to add 2x squared plus x plus 1 and 3x squared minus x plus 5. Before we continue, let us try to write this first in one expression. So of course, this is our first polynomial, so we enclose that inside a parenthesis as an indicator that this is our first polynomial. And don't forget, our translation of the word add is plus. Then our second polynomial is 3x squared minus x plus 5. Let us try to answer this using method 1 to add polynomials horizontally. Step 1 is simply to remove the parentheses for each polynomial. So that would become 2x squared plus x plus 1 plus 3x squared minus x plus 5. Let's now proceed to step 2. We combine like terms, starting with the terms with the highest degree of exponent. Looking at this one, let's try to check the degree of each term. This is 2, this is 1, this is 0 because it's just a constant term. This one is 2 because the exponent is 2 for x. Here it's 1. And finally, our 5 is just a constant term. So the degree of the exponent, or the degree is just a 0. So the highest now would be 2. So that means we have to start by combining the like terms for with 2x squared. So 2x squared, if you notice, 2x squared and 3x squared are like terms because they have the same literal coefficient, which is x squared. So we just have to combine their coefficients. So that's 2 plus 3. And then we copy the common literal coefficient. And then afterwards, we're done with this term. So in my case, I will highlight it so that I will not be confused. I am done considering this. So we're now down to 1. Because we're done with terms with a degree of 2. So we'll now proceed to the next one. So x. X here, and the x in here as well are like terms. And as you can see, this is a minus, right? So instead of thinking of a minus, we can think of it as plus negative x. Because that's the rule in subtraction. That we change minus to plus, but we get the opposite of what is next to it. So I will do a marking so that you will not be confused. So this one becomes a plus, but the x here becomes a negative x. So they are like terms because they have the same literal coefficient x. So what we do now, we just combine their coefficients. The coefficient of the x, there's an imaginary 1 here, so that's a 1. Here, this is a negative 1x, so plus negative 1. Then the common literal coefficient is x. So we're done with this. Finally, we have our constant terms, which are 1 and 5. So we can just combine them by putting them inside the parentheses. Then, finally, we just add 2 plus 3. That would be 5x squared. 1 plus negative 1 is 0. So 0x. 1 plus 5 is 6. Now 0 multiplied to anything is just a 0. So it's okay not to write 0x anymore, but just to write 5x squared plus 6. Now, the last step is to write the final answer in standard form. That means that the degree must be in decreasing order. But by checking this one, this is degree of 2, degree of 0. And that's in descending order already. That means this is our final answer. 5x squared plus 6. Now, let us try to answer this problem using method 2. Let's try to add polynomials vertically. So, first of all, we have to make sure that each polynomial is in standard form. So, the given polynomials are the following. So, we have 2x squared plus x plus 1. So, let's verify if it's already in standard form. The degree of the first term is 2. Degree of the second term is 1. Degree of the last term is 0. And it's already in decreasing order. That means it's a yes. So it's already in standard form. Next, our second polynomial is 3x squared minus x plus 5. This is degree of 2. Second term is degree of 1. Last term is degree of 0. So that's 2, 1, 0. So it's already decreasing. Therefore, it's already written in standard form. So we're now ready to continue to step 2. So write the polynomials in vertical columns in such a way that similar terms are in single column. Leave spaces for missing terms. So it's like saying that you just have to copy the first polynomial, 2x squared plus x plus 1. And then we go to our second polynomial. We start from our first term, 3x squared. We have to align it with the like terms coming from our first polynomial. So 2x squared and 3x squared are like terms, so you need to align them. The second term is a minus x, or we can say plus negative x. So the x in here in our first polynomial is the like term of the negative x. So we put it here below x. So that's positive, plus negative x. And then finally, the last term, 5, is a constant term similar to 1. So we put it below our 1. And then, we now combine similar terms. And what's nice with the vertical method, we're already assured that those who are aligned are like terms or similar terms. So this is 2 plus 3, that's 5. Then copy the common literal coefficient. This is 1 plus negative 1. So that means 0. Then 1 plus 5, 6. So this 5x squared plus 0x plus 6 can be written as 5x squared plus 6 because 0x is just 0 and there's no need for you to write 0. So this is our final answer. So feel free to choose which one would you prefer. vertical or horizontal. So it's up to you as long as you derive or arrive with the same answer. Let's have example 2. We're now asked to add 2x squared minus 3x plus 2 plus negative x squared plus x minus 2. In my case, I would like to use horizontal method for this one. So first of all, copy the given. That's 2x squared minus 3x plus 2 plus negative x squared plus x minus 2. We remove the parentheses, so that will become 2x squared minus 3x plus 2 plus negative x squared plus x minus 2. So just remember that what we will do next is similar to what we're doing before, in which we need to simplify the polynomial by combining like terms. So first, you have 2x squared. So check whether there is a like term. So upon checking, these two terms are like terms. And don't forget, this is a minus, and this is a negative x squared. So that means 2 plus, because that's a coefficient of 2x squared, plus negative 1. Because this is plus negative x squared. So, copy the common literal coefficient. So, put a marking that you're done with those terms so that you will not be confused. Next, this is a minus 3x. So, instead of thinking of a minus 3x, you think of it as plus, then from positive 3x to negative 3x. So this is plus negative 3x. So find its like term, which is here. Because they have the same literal coefficient, just x. So, plus, close parenthesis, this is negative 3. This is plus 1. Then enclosed, the common literal coefficient is x. So highlight, because you're done with it. This one, you're done with this. Next would be the two constant terms. We have plus 2, but this is a minus again. So instead of thinking of a minus, you'll think of it as plus. Then this one from positive 2 to negative 2. So this would be 2 plus negative 2. Because both are constant terms. So you're done considering all. You just have to combine, add our coefficients. So 2 plus negative 1 is just 1. So 1x squared. Negative 3 plus 1, negative 2x. 2 plus negative 2 is 0. Now there's no need for you to write 1. So just write x squared. Plus negative 2x can be written as minus 2x. Then plus 0, it's okay not to write plus 0. So this would be our final answer. X squared minus 2x. Let's proceed to example 3. So add 8x cubed minus 3x squared plus x minus 1 and 3 times the quantity of x squared plus 2x minus 5. So in this case, I will be using vertical method to answer this problem. So first of all, the difference between this example from the previous one, our first polynomial is fine, but our second polynomial has a parenthesis, and there is a number outside this. So that means you still have to simplify our second polynomial. So The given in our second polynomial is 3x squared plus 2x minus 3 times the quantity of x squared plus 2x minus 5. So with that, we need to distribute the 3 to each terms of our trinomial. So 3 times x squared, so that will become 3x squared. 3 times 2x is 6x. 3 times negative 5, because you can think of it as plus negative 5. So negative 5 times 3, that would be negative 15. Or you can just put minus 15 for that. And there you go. Now our first step in adding polynomials vertically, we need to make sure that it is in standard form. So let's review the degrees. So first term, wait, let me just copy it. This is our first polynomial, 8x cubed minus 3x squared plus x minus 1. So first term is degree of 3. This is degree of 2. This is degree of 1. This is degree of 0. It's in descending order, so that means it's already in standard form. The next polynomial, we have 3x squared plus 6x minus 15. So our first term has a degree of 2. Second term has a degree of 1. And finally, the last term has a degree of 0 because it's just a constant term. It's also in descending order, therefore it's already in standard form. Now we proceed to our step 2. We just have to copy our first term, first polynomial, 8x cubed minus 3x squared plus x minus 1. Now consider each terms in our second polynomial and make sure that you will align the like terms or similar terms. 3x squared, the literal coefficient is x squared. And it's the same here. This is also x squared. So you need to put 3x squared here. Next, 6x. The literal coefficient is x and it's similar to this. This is also an x. So plus 6x. And then finally, 15 is just a constant term similar to 1. It's also a constant term. So minus 15. Then you add. So notice that it doesn't have a like term from in our second polynomial. So just bring it down. Negative 3 plus 3 will give you 0. So no need to write 0. There's an imaginary one here. So in other words, we are adding 1 plus 6. So that would be 7. 7x. Then here, both numbers are negative. So negative 1 plus negative 15, we add them and then copy the common sign. So therefore, our final answer, that's 8x cubed plus 7x minus 16. Now, let's proceed to number 4. So we're asked to find the sum of 2a squared b minus 3b cubed plus 4a cubed plus 9ab squared. This is our first polynomial. Then second polynomial is 3a cubed minus 6b cubed. Our second polynomial. And finally, our last polynomial, the third one, is 4ab squared minus 3a squared b plus 2a cubed. In my case, I will be using vertical as a method to answer this problem. So, since the operation is just sum or add, I can do them simultaneously. So meaning no need to add two polynomials at a time because the operation is just plus. I just have to make sure that the terms, which are like terms, should be aligned correctly. So let's begin. Okay. Now, notice that in our first polynomial, all of the degrees here would be 3. Because this is 2 plus 1, so 3. This is 3 as well. This is 3. This is 1 plus 2, so 3. So, meaning no need to rearrange them. So, better you just copy it. 2a squared b, then minus 3b cubed plus 4, okay, wait, minus 3b cubed plus 4a cubed plus 9ab squared. Now, proceed to our second polynomial and align the like terms. So let's start with our first term. 3a cubed has a literal coefficient of a cubed. And similar to 4a cubed, the literal coefficient is also a cubed. That means these are like terms. So you need to align them. That will become, you will write 3a cubed here. Okay. Now, next term is a negative 6b cubed. Because again, you can just think of it as plus negative 6b cubed instead of thinking of minus 6b cubed. So, looking at here, this one has a literal coefficient which is b cubed. And this is b cubed as well. So that means these are like terms. So we put negative 6b cubed below here. Don't forget, between them, that's plus. Next, let's proceed to our third polynomial. That means we will make a third row for our third polynomial. So first, the first term here is 4ab squared. So look for an ab squared here in our first polynomial. So it's here. That means you need to align them. So we put 4ab squared. So that's a positive, so plus. Next would be the minus 3a squared b, but you can think of it as plus negative 3a squared b. So you look for a literal coefficient which is a squared b from our given. So it's here, a squared b. So with that, you just copy this below and write it below 2a squared b. So this is negative 3a squared b. So be careful with the sign. Don't forget this, that this is a negative, not a positive. Considering that we change the minus to plus and then we get the opposite of 3a squared b. So it becomes negative 3a squared b. Then finally, our last term is 2a cubed. So look for a term with a cube as well. So it's here. So we write positive 2a cubed here. And then finally, we can add. So 2 plus negative 3, different signs, so we need to subtract them. 3 minus 2 is 1. The greater value in terms of absolute value is 3. So we copy the sign of 3, which is negative. Then, copy a squared b. So again, do not do anything with a squared b. Just copy them because it's a common literal coefficient of both terms. Next, negative 3 plus negative 6 is negative 9. Then b cubed. Then here, 4 plus 3 is 7 plus 2 is 9. Then 9 plus 4, so 9 plus 4 is 13. Then copy ab squared. Okay, now, to write our final answer, we have to write them in order. So how will we know if what's the correct order? So first of all, follow the order of the alphabet. So we will begin with a term with an a only. So that would be 9a cubed. The next, consider a term with an a as well. But what comes first is the a with the highest degree. So here, we have a in both terms here. But a squared is greater, in terms of exponent, a 2 is greater than an exponent 1. So we write this first. But instead of putting a 1 here, it's okay not to write that anymore. It's understandable. So minus a squared b. Then afterwards, the other term with an a as well. So plus 13ab squared. And finally, the term with a b only, so minus 9b cubed. And this is our final answer. 9a cubed minus a squared b plus 13ab squared minus 9b cubed. Okay, let's try a problem related to perimeter. So when we say perimeter, we just have to add all the side lengths. That's the sum of all the side lengths. And in our case here, this is a rectangle. Knowing that two sets of sides are equal. So when you see this kind of symbol, this one, for example, you only see one tick mark. That means this is an indicator that both sides are equal in length. And since there are two tick marks here, and there are also two tick marks here, that means they're also equal in length. So if this is 2x, this is also 2x. If this is 3x minus 1, this is also 3x minus 1. So now, if you remember, the formula for perimeter is 2L plus 2W. Okay. Now, we have 2 times the quantity of our length. Okay, let's consider this as our length. This is our width. So, when you substitute, enclose it in a parenthesis, so L becomes 3x minus 1. Plus 2, we substitute 2x to W. So enclose it in the parenthesis, then 2x. So we will use horizontal to figure out the result for this one. So first of all, there are only two terms here, separated by the plus. Okay, wait. We'll use yellow para makita nyo. Okay, ito. So that means that looking at on the left side of our plus, we still have to multiply the 2 to the group, 3x minus 1. So we distribute. So 2 times 3x, so that will become 6x. Then 2 times negative 1, because this can be written as plus negative 1. So 2 times negative 1 is negative 2. So you can write it as minus 2 here. Then, for the 2 times 2x is 4x. Then we combine like terms. 6x and 4x are like terms because they have the same literal coefficient x. So 6 plus 4. So 6 plus 4 is 10. So 10x minus 2. Now, how about this figure? So as I mentioned a while ago, those tick marks will tell you the side lengths which are equal in length. So, in other words, if this is 4x plus 1, this is 4x plus 1 as well. If this is 3x, this is also 3x. So to find the perimeter, you just have to add all the side lengths. So looking at it, there's only one 3x plus 2. So perhaps you enclose it in a parenthesis. Plus, there are two 4x plus 1. Two sets of 4x plus 1. That's what I mean. That's what I mean. So 2 times the quantity of 4x plus 1. Then plus again, there are two 3x. So 2 times 3x. So we simplify this, remove the parenthesis, 3x plus 2. Here, this means that you need to distribute the 2. So 2 times 4x and 2 times 1. 2 times 4x is 8x. 2 times 1 is 2. And then, for our last term, so 2 times 3x, that would be 6x. Then we combine the like terms, 3x, 8x, and 6x, they have the same literal coefficient x. So that means 3 plus 8 plus 6. Then you have the constant terms, 2 and 2. So 2 plus 2. 3 plus 8 is 11. Plus 6 is 17. Then 2 plus 2 is 4. So this is our final answer to represent our perimeter of this figure. Let's have our last word problem about Ocean Park. The Manila Ocean Park is the Philippines' first world-class marine theme park. The cost of admission to Trails to Antarctica and Penguin Talk Show are given. Trails to Antarctica is 300 pesos per person. Penguin Talk Show is 150 pesos per person. Question now is, what is the total cost for X people visiting on Trails to Antarctica? So this X here represents the number of people, but we're not sure how many of them. So what would be the computation for our total cost? So looking at our pattern, okay, this is all about pattern. That's the purpose why we have algebra. Okay. If we will try to imagine one person going to Trails to Antarctica will be paying 300 pesos. So how will we get that? So 300 times 1. So 300 times 1, that means 300 pesos. If there are two persons visiting the Trails to Antarctica, so that means 300 times 2. So that would be 600. If there are 3 persons who will be visiting, so 300 times 3. So you will get 900. And so on. So if we don't know the number of people who will be visiting Trails of Antarctica, we represent that with a variable. And that is the 1, 2, 3 here. So that would be 300 times x. Or in other words, it's 300x. So this is our answer. Okay, how about the total cost for people visiting the Penguin Talk Show? Okay, so I will just be putting here kasi it will cover our solution a while ago. So it says that what is the total cost of X people visiting only the Penguin Talk Show? So in that's the case, we will figure out the pattern. So starting with one person. So if there's only one person who will go to Penguin Talk Show, that's 150 times 1. So the total cost would be 150 pesos. If there are two persons involved, so 2 times 150, 300 pesos. If there are 3 people who will visit the Penguin Talk Show, so 150 times 3, that would be 450. So that means in general, if we do not know the number of people visiting, we will represent that with an X. But Similar pattern, we multiply the number of people visiting times the cost per person, which is 150. So the answer would be 150x. Now, what if, this would be our last question, what if, what is the, okay, it's here. What is the total cost for X people visiting both the trails to Antarctica and the Penguin Talk Show? Okay, so in other words, um, I will put a marking here. This is B. And the C now is what if it's both. Okay, we already know that people who will be visiting the trails to Antarctica, that would be 300x. So we will simply add the total cost for those who will be visiting the Penguin Stock Show, so which is already represented by 150x. So if there's only one person who will be visiting both, so we replace x with 1. So 300 times 1 plus 150 times 1. So 300 plus 150, you will get 450 pesos. If there are two persons involved, so we replace x with 2. 300 times 2, 600. 150 times 2, 300. And we add them, 600 plus 300. So all in all, it's 300. So in other words, this one represents the total cost if a person will visit both. We can still simplify this by adding 300x plus 150x. Okay, the total cost for Trails to Antarctica plus the total cost who will be visiting Trails to Antarctica, then that would be our total cost all in all. So 300x plus 150x is just 450x because these are like terms. They have the same literal coefficient x. So this is our answer for C, this is our answer for A, this is answer for B.